Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about problems on temporary and permanent and total hardness in ppm, parts per million, and degree of clerks. So before going to discuss these problems, first what is the meaning of water or hard water or hardness of water? So it containing calcium, magnesium ions of bicarbonates, chlorides, sulfates present in water. So that's why when we treat it with soap, it doesn't produce lather. But in soft water, absence of all these ions. So when we treat it with soap, it produces lather. That is the main reason hard water, when we treat it with soap, it doesn't produce lather because of its presence calcium, magnesium ions of bicarbonates, chlorides, sulfates. So that is called hardness of water. So this hardness of water or hardness is classified into two types: temporary hardness and permanent hardness. So temporary hardness, it is mainly caused by due to the presence of calcium, magnesium bicarbonates or bicarbonates of calcium and magnesium. So calcium, magnesium bicarbonates present in water. So that water is considered as temporary hardness of water or temporary hardness. So it can be easily removed by boiling. It can be easily removed by boiling. So generally these calcium bicarbonates or magnesium bicarbonates starting in water, these are soluble in water. It cannot be visible. So these are soluble in water. So during boiling process, for example, in water is present calcium bicarbonates. So during heating process, so here water can generally it's present calcium, magnesium bicarbonates in water. That water is considered as temporary hardness of water. So if in case this calcium bicarbonate present in water, so these are soluble in water. These are soluble in water. So during heating process, the soluble calcium bicarbonates or magnesium bicarbonate is converted into insoluble precipitates. Insoluble precipitates, white color precipitates are formed. That is called the presence of calcium carbonate. So this calcium bicarbonate during heating process, it converted into calcium carbonate precipitate. So in this way, temporary hardness easily we can remove by boiling. If in case magnesium bicarbonate present in water, so these are also soluble in water. So during heating process, this soluble magnesium bicarbonate is converted into insoluble magnesium hydroxide precipitates. For example, in our homes, we observe when we are heating this water in steel bowls. So after some time, it forms white color precipitates in edges of that bowl. That is called calcium or magnesium bicarbonates. Precipitates form in conversion during heating process, calcium carbonate or magnesium hydroxide. So it can be easily removed by boiling after filtration. So permanent hardness, it is due to the presence of dissolved salts of chlorides, sulfates present in water. Calcium, magnesium ions of chlorides, sulfates or nitrates present in water. So here, this permanent hardness we cannot remove by boiling. So what are the permanent hardness responsible salts are? Calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate, ferrous sulfate and aluminium sulfate. And most important permanent hardness causing salts are calcium, magnesium, chloride, sulfates. And this permanent hardness we cannot be removed by boiling, but it can be removed by use of some chemical agents. For example, internal treatment method. Internally we are adding some chemicals in water like Calgon, or external treatment methods or by scrubbing. We can remove this permanent hardness causing salts or precipitates. So in this way, hard water means it is a combination of temporary hardness causing salts and permanent hardness causing salts is called total hardness of water. So temporary hardness causing salts means calcium, magnesium ions of bicarbonates present in water. It can be easily removed by boiling. But permanent hardness means it is its presence permanent hardness causing salts like calcium, magnesium, chlorides, sulfates or nitrates present in water. So this permanent hardness we cannot be removed easily by boiling, but it can be removed by using some chemical agents. And most important concept is for numerical purpose, expression of hardness in terms of CaCO3 equivalent. So all the hardness causing salts which are present in water or which are given in the data. So all these are hardness causing salts, we can convert it into calcium carbonate equivalent or equivalence of CaCO3. Why? Why we are converting the CaCO3 equivalent terms? What is the reason? Because this calcium carbonate molecular weight is 100 and equivalent weight is 50. So the calculation in water analysis, it can be simplified when we converted all the hardness causing salts present in water in CaCO3 equivalence. So it makes calculation is very easy. And one more important thing is it is most insoluble salt. It is most insoluble salt. So that can be precipitated in water treatment. That can be precipitated in water treatment. So the conversion of hardness causing salts into CaCO3 equivalent, it can be achieved by using this formula. So what is the formula we are using? This hardness causing salts converted into equivalence of CaCO3. So it's equal amount of hardness causing salt by molecular weight of hardness causing salt into 100. For example, in the problem it's given 50 kilograms of magnesium sulfate present in water. So amount of hardness causing salt, that means amount of magnesium sulfate is 50 milligrams. And molecular weight of hardness causing salt is, that means molecular weight of magnesium sulfate here, that is a 120. So it's equal 50 by 120 into 100 is equal dash milligram per liter or parts per million. So here in this way we can convert it all the hardness causing salts which are present in water or whatever given in the data. First we convert it into calcium carbonate equivalent. Why we prefer, why all the hardness causing salts were converted into CaCO3 equivalent? Because calcium carbonate is highly insoluble in water and its molecular weight is 100 and equivalent weight is 50. So it makes calculation is very easy. Now we should remember before solving these problems based on this permanent, total and temporary hardness of water. So we should remember the molecular weight of hardness causing salts. So here again all the hardness causing salts molecular weights in this slide. So calcium bicarbonate's molecular weight is 162 and magnesium bicarbonate molecular weight is 146 and magnesium nitrate 148 and magnesium sulfate 120 and magnesium carbonate 84 and magnesium chloride is 95 and calcium nitrate is equal 164 and calcium carbonate is equal 100, calcium sulfate 136 and calcium chloride 111 and calcium 40 and magnesium 24. So these are the most important hardness causing salts molecular weights. They are most important for numerical purpose, for determination of total hardness, permanent hardness and temporary hardness. So in this way we should remember this molecular weights of hardness causing salts. Now let's discuss numericals based on that hardness, total hardness, permanent hardness, temporary hardness causing hardness in water. So first one is 1 liter of water sample. So 1 liter of water sample collected from a water source in Telangana. Has shown in following analysis. So according to this data, so magnesium carbonate weight is 14.6 milligrams. Magnesium bicarbonate is 14.6 milligrams. And magnesium sulfate is 12 milligrams. Magnesium sulfate 12 milligrams. And calcium bicarbonate is 16.2 milligrams. And calcium chloride is 22.2 2 milligrams. And magnesium chloride is 9.5 milligrams. And other organic impurities are 100 milligrams present in water. So now calculate the temporary and permanent hardness in degree of French. So in this water is present in Telangana, 1 liter of water sample collected from water source. It's said in Telangana only. So in this water, in this 1 liter of water, it's containing the weight of or amount of hardness causing salts are magnesium bicarbonate is 14.6, magnesium sulfate is 12 milligrams, calcium bicarbonate is 16.2 and calcium chloride is 22.2 milligrams and magnesium chloride is 9.5 milligrams. So now and other organic impurities also present in that water, but we cannot consider this one. It is negligible. We can ignore because these are not participating in this hardness. We cannot use it for calculation of total hardness or permanent hardness or temporary hardness. So if in case other data not related to hardness causing salts, so we can ignore. If in case it mention that percentage or weights in that problem or data, we can ignore. So now all the hardness causing salts whatever given in the data, so all are converted into equivalents of CaCO3. So how can we convert this hardness causing salt in CaCO3 equivalent? So it's equal amount of hardness causing salt, amount of hardness causing salt in terms of CaCO3 by molecular weight of hardness causing salt into 100. Why we are converting all the hardness causing salt in CaCO3 equivalent? Because it makes calculation is very easy. Why you have to prepare only CaCO3? So many hardness causing salts present in water, but we preferred only CaCO3 because its molecular weight is 100 and equivalent weight is 50 and it is highly insoluble in water. So it makes calculation is very easy. So that's why we converted all the hardness causing salt in CaCO3 equivalent terms by using this formula. So it's equal amount of hardness causing salt by molecular weight of hardness causing salt into 100. So here, so already we know that weight of magnesium bicarbonate is 14.6, magnesium sulfate is 12 milligrams, calcium bicarbonate is 16.2 and calcium chloride is 22.2 milligrams and magnesium chloride is 9.5 milligrams given in that data. So then we converted into calcium carbonate equivalent. So what is the formula? It's equal weight of hardness causing salt by molecular weight of hardness causing salt. Molecular weight of hardness causing salt into 100. So by using this formula, we can convert it all the hardness causing salt into CaCO3 equivalent. So first one is magnesium bicarbonate. So weight of hardness causing salt, that is the magnesium bicarbonate is 14.6. We can substitute here 14.6. Weight of magnesium bicarbonate is 14.6. By molecular weight of magnesium bicarbonate is 146 into 100. So it's equal 10 ppm. It's equal 10 ppm. Next, calcium bicarbonate. Second salt is present in water. Calcium bicarbonate. Its weight is 16.2 milligrams. So we can substitute in this formula. Weight of calcium bicarbonate is 16.2 and molecular weight of calcium bicarbonate is 162 into 100. 16.2 by 162 into 100 is equal 10 ppm. It's equal 10 ppm. And next third one is magnesium sulfate. So it's also same formula we are using here. It's equal weight of magnesium sulfate is 12 milligrams. So 12 by molecular weight of magnesium sulfate is 120. So 12 by 120 into 100 is equal 10 ppm. It's equal 10 ppm. And next one is calcium chloride. Calcium chloride. So it's equal, weight of calcium chloride is 22.2. 22.2. And molecular weight of calcium chloride is 111. So 22.2 by 111 into 100. Then we'll get 20 ppm. And last one is magnesium chloride. How much amount present in that water? 9.5. So weight of magnesium chloride is 9.5 by molecular weight of magnesium chloride is 95 into 100. So 9.5 by 95 into 100 is equal, after calculation you will get 10 ppm. So in this way we can convert all the hardness causing salt into CaCO3 equivalent by using this formula. Weight of hardness causing salt by molecular weight of hardness causing salt into 100. So now we can calculate temporary hardness and permanent hardness of water. So temporary hardness causing salts. So first step is all the hardness causing salts converted into CaCO3 equivalent. So it's done already. It's completed. Next, second one is most important. We can identify the temporary hardness causing salts and permanent hardness causing salts. So what are the temporary hardness causing salts? Starting we discussed already. Temporary hardness causing salts are calcium bicarbonates and magnesium bicarbonates. So here magnesium bicarbonates are 10 ppm present in that water and calcium bicarbonates are 10 ppm present in that water. So temporary hardness is equal calcium bicarbonate plus magnesium bicarbonate. It's equal 10 plus 10. So it's equal 20 ppm. So temporary hardness of this water is 20 ppm. Next, second one is permanent hardness. Permanent hardness. So what are the permanent hardness causing salts? So calcium, magnesium ions of chloride, sulfates or nitrate present in that water. So that water is considered as permanent hardness of water. So in this data it's present permanent hardness causing salts are magnesium sulfate, calcium chloride and magnesium chloride. So when we after conversion we'll get the values of calcium chloride, magnesium chloride and magnesium sulfates are 20 plus 10 plus 10. So it's equal 40 ppm. So permanent hardness of given water is 40 ppm. So first step is first hardness causing salts all are converted into calcium carbonate equivalent. Next, second one is identify the temporary hardness causing salts and permanent hardness causing salts. Then calculate the temporary hardness and permanent hardness of given water. Next, we can convert it into French degrees. So what is the basic relationship of all the units of water? So generally units of water is ppm, milligram per liter, degree of Clerk, degree of French. So what is the basic relationship between all the units of water? 1 ppm equals 1 milligram per liter. It's equal 0.07 Clerk degree. It's equal 0.1 French degrees. So now you can convert a temporary and permanent hardness into French degrees. So what is the value of French degree? 0.1. So total temporary hardness into 0.1, then converted into French degrees. So your temporary hardness is 20 ppm. So when you convert it into French degrees, 20 into 0.1, it's equal to French degrees. Next, permanent hardness converted into French degrees. So permanent hardness is 40 ppm. When we convert it into French degrees, so 40 multiplied with 0.1, it's equal 4 French degrees. So in this way we can convert it hardness into temporary French degrees. Next, one more problem we'll discuss. So 1 liter of water from an underground reservoir in Tirupati town. 1 liter of water from an underground reservoir in Tirupati town in Andhra Pradesh. Show the following analysis for its contents. So in this, magnesium bicarbonate is 42 milligrams, calcium bicarbonate is 146, calcium chloride is 71, magnesium sulfate is 48 And now we can calculate the temporary, permanent and total hardness of this sample of 10,000 liters of water. Not 1 liter here, it's given already 10,000 liters of water. So 1 liter of water from underground reservoir in Tirupati town in Andhra Pradesh. So in that water is present, what are the hardness causing salts weights? It's present magnesium bicarbonate, calcium bicarbonate, calcium chloride and magnesium sulfate present in that water. So first, what is the first step in there? All the hardness causing salts converted into CaCO3 equivalent terms. So what is the formula we can for conversion of equivalent of CaCO3? So amount of hardness causing salt by molecular weight of hardness causing salt into 100 into 100. So we convert into CaCO3 equivalent. So here in the data, from the data, magnesium bicarbonate is 42 milligrams, calcium bicarbonate is 146 milligrams and calcium chloride is 71 milligrams and magnesium sulfate is 48 milligrams. So now how can we convert this hardness causing salt into CaCO3 equivalent terms? Weight of hardness causing salt by molecular weight of hardness causing salt into 100. So first we converted magnesium bicarbonate in CaCO3 equivalent terms. So here weight of magnesium bicarbonate is 42 by molecular weight of magnesium bicarbonate is 146 into 100. It's equal 28.76 ppm. After calculation, get 28.76 ppm. ppm is the parts per million units of hardness. And next, calcium bicarbonate. So what is the weight of this calcium bicarbonate present in that water, given water? 146 by molecular weight of calcium bicarbonate is 162. Molecular weight of calcium bicarbonate is 162 into 100. So 146 by 162 into 100. After calculation, we get 90.12 ppm. So next, converted into magnesium sulfate in CaCO3 equivalent. So what is the weight of magnesium sulfate? 48 by molecular weight of magnesium sulfate is 120. So 48 by 120 into 100, it's equal 40 ppm. And finally, you can convert calcium chloride into CaCO3 equivalent. So weight of calcium chloride is 71 milligrams. 71 milligrams. So here 70 weight of calcium chloride is 71 and molecular weight of calcium chloride is 111 into 100. It's equal 63.96 ppm. 63.96 ppm. So temporary hardness equals. So first part is completed. So that hardness causing salts converted into CaCO3 equivalent. Now you can calculate the temporary hardness. So what are the temporary hardness causing salts? In the data, magnesium bicarbonate and calcium bicarbonate. These two are the temporary hardness causing salts. So after conversion, we'll get in CaCO3 28.76 and calcium bicarbonate value is 90.12. So after addition, we'll get 118.88 ppm. So temporary hardness of given water is 118.88 ppm. Next, we'll calculate the permanent hardness. So now I identified the permanent hardness causing salts present in given water. So magnesium sulfate and calcium chloride. Magnesium sulfate and calcium chloride. So after conversion, we'll get magnesium sulfate value is 40 ppm. So you can substitute here and plus calcium chloride value is 63.96. So after addition, we'll get 103.96 ppm. Okay. So permanent hardness of given water is 103.96. So temporary hardness of given water is 118.88 ppm and permanent hardness of given water is 103.96 14.96 ppm. So total hardness of given water is equal. So total hardness means temporary hardness plus permanent hardness of water. So just now we discussed already, we can calculate it here. Temporary hardness is 118.88. Permanent hardness is 103.96. So 118.88 plus 103.96. After addition, you'll get 222.84 ppm. So total hardness of given water is 222.84 ppm. So now we can calculate we can convert it into 10,000 liters of water. So how can we convert it 10,000 liters of water, this hardness? So this hardness, temporary hardness into 10,000 or permanent hardness into 10,000. In this way, we can calculate the hardness present in 10,000 liters of water. So now we can calculate the permanent hardness in 10,000 liters of water. So permanent hardness is 103.96 ppm. So 103.96 into 10,000. It's equal 10,39,600 ppm. And same way we can calculate the temporary and total hardness of water in 10,000 liters of water. So temporary hardness equal, temporary hardness is 118.88 into 10,000 liters of water. So 118.88 multiplied with 10,000. It's equal 11,88,800 ppm. Now you can calculate the total hardness. So total hardness is equal 222.84 ppm. So 222.84 into 10,000. It's equal 22,28,400 ppm. So in this way you can calculate the temporary and permanent total hardness in 10,000 liters of water. Next, third one. A sample of water is found to contain following analytical data in milligram per liter. So here magnesium bicarbonate is 14.6, magnesium chloride is 9.5, magnesium sulfate is 6 and calcium bicarbonate is 16.2. So calculate the temporary permanent hardness of water in parts per million and degree of Clerk and degree of French. So all these are the units of water. So here, what is the first step? So all the hardness causing salts converted into CaCO3 equivalent terms or equivalent of CaCO3. We have converted all these in CaCO3 equivalent because it makes calculation is very easy. So what is the formula we are using here? Weight of hardness causing salt. Weight of hardness causing salt by molecular weight of hardness causing salt into 100. So by using this formula we can calculate, we can convert it all the hardness causing salt into equivalent of CaCO3. So what are the hardness causing salts present in water, given water or given the data? So magnesium bicarbonate, magnesium chloride, magnesium sulfate, calcium bicarbonate present in that water, given water. So how much amount of this hardness causing salts present in that water? So magnesium bicarbonate weight is 14.6, magnesium chloride 9.5, magnesium sulfate is 6, calcium bicarbonate is 16.2. So what are the molecular weights of the hardness causing salts which are present in that water? So magnesium bicarbonate is 146 and magnesium chloride is 95 and magnesium sulfate is 120 and calcium bicarbonate is 162. So these are the molecular weights of given hardness causing salts. Now you can convert it into equivalent of CaCO3. So what is the formula? Weight of hardness causing salt by molecular weight of hardness causing salt into 100. So weight of magnesium bicarbonate is 14.6. Molecular weight of magnesium bicarbonate is 146. So 14.6 by 146 into 100 it's equal 10 milligram per liter. Next, magnesium chloride. Weight is 9.5. Molecular weight is 95. So 9.5 by 95 into 100. It's equal to 10 milligram per liter. And next, magnesium sulfate. So weight of magnesium sulfate is 6. Molecular weight of magnesium sulfate is 120. So when we substitute it in this formula, 6 by 120 into 100, it's equal 5 milligram per liter. 5 milligram per liter. And next one is calcium bicarbonate. Calcium bicarbonate. Weight of calcium bicarbonate given in this data is 16.2. Molecular weight of calcium bicarbonate is 162. So 16.2 by 162 into 100 is equal 10. So in this is step 1. You can convert it to all the hardness causing salts in CaCO3 equivalents. Because it makes calculation is very easy. That's why all the hardness causing salts converted into CaCO3 equivalents. Next, you can identify the temporary hardness causing salts. So what are the salts present in that water? Magnesium bicarbonate and calcium bicarbonate. So what are the temporary hardness causing salts present in that water? Given water, magnesium bicarbonate and calcium bicarbonate. So here magnesium bicarbonate value is 10 after conversion in equivalent of CaCO3. Calcium bicarbonate is also 10. So it's equal to 20 milligram per liter. 20 milligram per liter. So when we convert it into ppms, Clerk's degree, French degrees, it's given in the data milligram per liter. So we can convert it into ppm, Clerk's degree and French degree. So how can we convert this hardness, temporary hardness in degree of Clerk, degree of French? So you should remember before that basic relationship between all the units of hardness. So what is the relationship? That is 1 ppm equal 1 milligram per liter. So both are equal. And it's equal how many Clerk's degrees? 0.07 Clerk's degrees and 0.1 French degrees. So here temporary hardness of water is 20 milligram per liter. So here 20 milligram per liter. So when we convert it into ppm, generally ppm 1 milligram per liter equal 1 ppm. So here 20 milligram per liter equal 20 ppm. Then convert it into Clerk's degree. So Clerk's degree into 0.07. So 20 into 0.07 it's equal 1.4 Clerk's degree. Then convert it into French degrees. So 20 into 0.1 it's equal to French degrees. So again we write this one 20 milligram per liter it's equal 20 ppm and it's equal 1.4 Clerk degree and 2 French degrees. After conversion, this is temporary hardness in parts per million, degree of Clerk and degree of French. Now let's discuss permanent hardness. So what are the permanent hardness causing salts present in given water? Magnesium chloride and magnesium sulfate. So this hardness causing salts converted into equivalent of CaCO3. Then we can get magnesium chloride value is 10, magnesium sulfate is 5. So total permanent hardness is 10 plus 5 is equal 15 milligram per liter. 15 milligram per liter. So 15 milligram per liter it's equal how many ppms? So mathematically 1 ppm equal 1 milligram per liter. Both are equal. So here 15 milligram per liter equal 15 ppm. Both are equal. And then how can you convert it Clerk's degrees? 1 ppm equals 0.07 Clerk's degrees. So 15 milligram per liter equal how many Clerk's degrees? So 15 into 0.07 it's equal 1.05 Clerk's degree. Next, how many French degrees? Generally 1 milligram per liter equal 0.1 French degree. So 15 milligram per liter equal how many French degrees? So 15 into 0.1 is equal 1.5 French degrees. So total permanent hardness is 15 milligram per liter. It's equal How many ppms? 15 ppms. And how many clerk degrees? 1.05 clerk degree. And it's equal to 1.5 French degrees. This is the basic relationship. That means permanent hardness converted into ppm, degree of clerk, degree of French. And one more problem discussed on based on that temporary hardness and permanent hardness. So here a sample of water is found to contain following dissolved salts in milligram per liter. So magnesium bicarbonate is 73 and calcium chloride is 111, calcium bicarbonate is 81 and magnesium sulfate is 40 and magnesium chloride is 95. So calculate the temporary and permanent hardness and total hardness of given water. So what is the step 1? Already we discussed previously. All the hardness causing salts which are present in water. That means here it's present hardness causing salts are magnesium bicarbonate, calcium chloride, calcium bicarbonate and magnesium sulfate and magnesium chloride. So all different hardness causing salts are present in that water. So all these are converted into equivalent of CaCO3 because it makes calculation is very easy. And why you have prepared only CaCO3? Because it is highly insoluble in water and its molecular weight is 100 and equivalent weight is 50. So that makes calculation is very easy. It is easily simplified. Water calculation analysis. It is simplified. So now converted into CaCO3 equivalent terms by using what is the formula? Weight of hardness causing salt by molecular weight of hardness causing salt into 100. So magnesium bicarbonate weight is from the data 73 and molecular weight is 146. So weight of magnesium bicarbonate is 73 and molecular weight of magnesium bicarbonate is 146 into 100. So it's equal 50 milligram per liter. And next calcium chloride. Calcium chloride weight is 111. And molecular weight of calcium chloride is 111. So when we substitute in that formula, 111 by 111 into 100, it's equal 100 milligram per liter. And next calcium bicarbonate, its weight is 81. And molecular weight of calcium bicarbonate is 162. So weight of calcium bicarbonate is 81. Molecular weight is 162. So 80 by 162 into 100, finally get 50 milligram per liter. And next magnesium sulfate. Weight is 40 and molecular weight of magnesium sulfate is 120. 40 by 120 into 100. It's equal to 33.3 milligram per liter. And last one is magnesium chloride. So what is the weight of magnesium chloride present in that water? 95. So weight of magnesium chloride is 95 by molecular weight of magnesium chloride is 95 by 95 into 100. It's equal 100 milligram per liter. So in this way we can convert it hardness causing salt into CaCO3 equivalent. Next, we can identify the temporary hardness causing salt, then calculate the temporary hardness of water. So temporary hardness causing salts are present in that water is magnesium bicarbonate and calcium bicarbonate. So its values are when we convert it into equivalent of CaCO3, magnesium bicarbonate is 50 milligram per liter in that water and calcium bicarbonate is 50. So temporary hardness equal 50 plus 50 is equal 100 milligrams per liter. 100 milligrams per liter. Next, permanent hardness causing salts are in that water, present in that water is calcium chloride, magnesium sulfate and magnesium chloride. So calcium chloride value after conversion in CaCO3 equivalent, its value is 100 and magnesium sulfate is 33.3 and magnesium chloride is 100. So after addition, we will get 233.3 milligrams per liter. So permanent hardness is 233.3 milligrams per liter. Next, we can calculate the total hardness of water. So total hardness equal temporary hardness plus permanent hardness. So temporary hardness is calculated just now 100 and permanent hardness is 233.3. So 100 plus 233.33 is equal 333.3 milligrams per liter. So temporary hardness of given water is 100 milligrams per liter and permanent hardness of given water is 233.3 milligrams per liter and total hardness of given water is 333.3 milligrams per liter. So in this way, you can calculate the total temporary and permanent hardness of water. So in this session, we'll learn about how can we calculate the temporary hardness, permanent hardness and total hardness, and how can we convert the degree of French and degree of Clerk. So in that first step is, first all the hardness causing salts converted into calcium carbonate equivalent. Then after that, we can identify the hardness, temporary hardness causing salts and permanent hardness causing salts. Then I can calculate the temporary hardness and permanent hardness, and after that we can calculate total hardness. Then after we can convert it into degree of Clerk or degree of French, whatever given in the data. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.